today we're going to take a look at exponential growth. So when you have an exponential equation or an exponential function, it's going to look something like this. You're going to have y equals some number to the power of x. So in the example that we're going to look at, our a value is going to be 2. So we're going to take 2 to the power of x. So I've filled in some values for my x starting at -2 and going all the way to +4. And what we're going to do is we're going to fill in this table using this exponential equation here. And we're going to show how this number grows exponentially, how 2 is going to grow exponentially. So the first one I'm going to look at is 2 to the -2 power. I'm going to write this over here in green so that you all can see. So if I have 2 to the -2 power, my rules about exponents tell me that if I have a number raised to a negative power, I have to write it as a fraction and move that value, if it's in the numerator, to the denominator and vice versa. So since 2 to the -2 would be at the top of our fraction in our numerator, I'm going to remove the negative and move it to the bottom, and that's going to become 1/4. So our value over here in our table is going to be 1/4. Then 2 to the -1 power, again, I'll do that one down here in green as well. So 2 to the -1 power is 1/2 to the 1, which becomes 1/2. And then from here on out, it should be pretty straightforward. So let me erase this down here. So 2 to the power of 0, anything to the power of 0 is 1. 2 to the 1 power is 2. 2 squared is 4. 2 to the 3rd power, well, that's going to be like 2 times 2 times 2. It's not 6. A lot of people want to jump in and say it's the same as 2 times 3. It's not. 2 times 2 is 4. Times 2 is going to give us 8. Then finally, 2 to the 4th power is going to be 16. So I'm going to graph these points now, and then we're going to show what this graph looks like. So I'm going to go down here, and let's see. At -2, it was 1/4. Now my scale on my x-axis is by 1s. My scale on my y-axis is by 2s to give me enough room to graph this. So 1/4 is going to be like way down here. At -1, it was 1/2. It's going to be about there. At 0, it was 1. Then at 1, it went up to 2. At 2, it jumps up to 4. At 3, it jumps up to 8. And at 4, it jumps up to 16. Now, if I were to take this out to 5, it would end up being 32. 6 would be 34. It's going to continue to get bigger and bigger. So if I were to draw this graph, it's going to look something like this. All right, so let's take a look at another example. We'll see kind of how this exponential graph works with a little bit different function. So if I scroll down here, now my function says, well, I've got 4 times 2 to the power of x. Okay, so order of operations tells us that we have to take our exponent first and then multiply by 4. So we've already done 2 to the power of x. That was our first example. So we're going to take each of those answers and multiply by 4. So in the previous example, we talked about how 2 to the power of -2 is actually 1/4. Well, 1/4 times 4 gives me 1. And we talked about how 2 to the power of -1 was 1/2. Well, 4 times 1/2 is 2. 2 to the power of 0 is 1. 1 times 4 is 4. 2 to the power of 1 is 2. And then 4 times 2 is 8. 2 to the power of 2, or 2 squared, is 4. And 4 times 4 is 16. And finally, 2 to the power of 3 was 8. And 8 times 4 is 32. So I'm going to graph these points. And again, I adjusted my scale a little bit to give me room to do this. So my x values are going by 1s. My y values are going by 3s. So at -2, this time, I'm at 1. At -1, I'm at 2. At 0, I'm at 4. At 1, I'm at 8. At 2, I jump up to 16. 3, I jump up to 32. And again, I'm going to draw a line to connect these points. And you can see how exponential growth looks on a graph.